Hello everyone, Gene Netch here, and welcome to the first grade. Here's what we're going to cover: the digits and the history of the numbers, the number line and zero, counting in order, less, more, or equal, and some basic addition. Alright, let's start with zero. So over here we have the evolution of the zero as being used as a dot. That was the first representation of zero. Zero kind of serves as the anti-hero in arithmetic and numbers as you study them. When we multiply zero with any other number, it makes the resulting value zero, kind of like a virus that attacks healthy cells. On the other hand, zeros do nothing when we add or subtract them with other digits, while making really any situation completely undefined when zero is in the denominator when we deal with fractions and polynomials. Which leads us to limits and the foundations of calculus. You'll get there soon. Like by 12th grade. For example, 100 divided by 0 is undefined. Like, how do you take $100 and cut it into 0 pieces or 0 piles? You can't do that. You can't take 100 and divide it by nothing. So we say it's undefined or does not exist for now. When we divide anything by 0, it stops to exist, and we say undefined. And you can try this on your calculator or iPhone. Just try. Put any number in, divide it by 0, and you'll get error. Although 0 sounds terrible at first, in the case described by division, 0 actually acts like some kind of portal between defined and undefined. And it's very useful in algebra. Like in 8th grade, you'll find zeros cancel stuff out and make our life very easy. For example, my students have learned the power of 0, like I was just saying in algebra, canceling things out, regarding addressing stress and anxiety. When we divide and multiply our anxiety by 0, we cancel it out. All right, let's get to 1. The first number recorded. It was an etched stick. That's a 1, okay? And then it kind of evolved, and now it's an upright 1. 1 is going to be the hero or the thesis in this story. Unlike 0, 1 times anything hides the number, and it's the marker of all. Plus or minus 1 second, plus or minus $1, years, moments, memories, points, pounds, and electrons. Neutrons are the hidden zeros, but change and field have inversion properties that are fascinating to study in quantum physics. 1 has the superpower of being invisible in algebra, building empires, turning stones to sand, and withstanding the force of time itself. 1 cannot be wrong because it stands next to nothing. It has nothing to compare it to, right? 1 is precision, 1 result, 1 sale, 1 day, 1 moment that makes everything possible. 0 plus 1, the beginning, means the good guys always win, or the synthesis of dark versus light. 2. All right, so 2, here's the evolution of the number 2. 2 is my wife's favorite number. 1 plus 1 is 2. When two good things are in perfect harmony, they make a perfect balance. And the number 2 is expressed in nature, and such balance is seen in nature. Helium is the most stable gas and element, has an atomic number of 2. When you square any value, you get the perfect square value, or the area in relation to one leg. 90 degrees comes from squaring lines, and Pythagoras used the power of 2 to discover the Pythagorean theorem, which paved the way for construction, and we still rely on that 90-degree angle to build homes and skyscrapers alike. To square a debt means to pay it off. To be square with someone means to be in equal accord. 2 is balance. Use the power of 2 to square your infinite tasks. 3. There it is. There it is. To this day, 3 is written as 3 lines, like in the Roman and Chinese numerals. The Greeks thought the Platonian solid shape of the triangle, or 3, represented fire. 3 has the power to make even things odd and odd things even through arithmetic. Check this out. 1 plus 2 is 3. 1 plus 1, which is 3, minus 2 is 1. 3 is a rough approximation of pi, and a very rough approximation of e, which we deal with log and exponential growth. The number of non-collinear points, which means not in one line, needed to determine a plane and a circle is at least 3. So you need at least 3 points to call a plane. Just like we say 2 points to a line, we need at least 3 points to describe a plane, like a 3D plane, the one that we live in. The first odd prime number and the second smallest prime is 3. 3 is also a Fermat number, which means 2 raised to the power of 2 raised to the power of n plus 1 is 3. It's also a mezzanine number. 2 times 3, which is 6, minus 1 is 5. And it's the second factorial prime. So 2 to the exclamation point would be 2 plus 1, which is 3. There we go. And it's also a second Lucas prime, which we'll learn about all these crazy numbers later. It's a second triangular number, and it's the only prime triangular number. It's the fourth Fibonacci number, and it's the smallest number of sides that a simple, non-self-intersecting polygon can have. So we need at least 3 sides to make a polygon, non-intersecting sides. That makes a triangle, like that represents the whole fire thing that the Greeks talked about. 4 is north, west, south, east. Okay, the word 4 has 4 letters, and in the English language, no other number has that property. The number 4 on a calculator is made up of 4 light bars. Many things are arranged in 4s. There are 4 suits in a deck of cards, 4 points on a compass, north, west, south, east. 4 phases to a moon. There are 4 wings on a bee and 4 leaves on a clover if you're lucky. There are 4 seasons. They are spring, summer, autumn, and winter. This theme of 4, whether it's expressed through seasons or anything I've mentioned, has been an inspiration for artists and composers such as Vivaldi, and for countless takeaway pizza establishments. A tetrahedron is a kind of pyramid with 4 triangular faces. It also has 4 corners. It's basically a square base that makes a pyramid top. 5 represents manifestation. There it is. That's the evolution of the glyph 5, how we got to it. We have 5 fingers, and that's why 5 is known for manifestation, because we use our hands to manifest basically everything. 5 is also a natural number. 5 is an odd number. 5 is the only prime number that is the sum of 2 consecutive prime numbers. Okay, 2 plus 3, namely 2 and 3. 5 is also the only prime number to end with 5 in the ones place. 5 is also the only prime, we'll study primes later, so bear with me, of 2 consecutive primes, mainly 2 and 3. And it's the number 5 is the 5th Fibonacci number, being 2 plus 3 as well. And it's the only Fibonacci number that is equal to its position. That's why it's the power number. 6 is the smallest positive integer, which is neither a square number nor a prime number. 6 is the second smallest composite number. Composite means it comes from 2 different numbers. And its proper divisors, which numbers can it come from, are 1, 2, and 3. Since 6 equals the sum of proper divisors, 6 is the smallest perfect number. There are 6 basic trigonometric functions, which we'll get to in 10th grade. There are 6 convex regular polytopes in 4 dimensions. The 6 exponential theorems guarantees, given the right conditions on the exponents, that the transcendence of at least one of the set of exponentials. All primes above 3 are in the form of 6n plus 1. All primes above 3 are in this form. The biology of our cells and a beehive are 6-sided as well. In the universe, there are 6 types of quarks and 6 types of leptons, which we'll learn in 12th grade, and which are the building blocks of all matter. But if you're just starting, you just need to know that there's really 6 tastes of food, right? Sweet, sour, salty, bitter, pungent, and astringent. 7. There it is. There are 7 days in a week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, if you don't already know. And God took the seventh day off. Okay, 7 is mysterious for that reason. What was he doing? 7 is the only dimension besides the familiar 3 in which a vector cross product can be defined. We'll get to that in 12th grade. Almost all mammals have 7 cervical vertebrae. Those are those like little bones like in the neck that like connect the head to like the body. There's like 7 of those vertebrae that make up the neck. Ironically, there are 7 types of viruses according to the Baltimore classification. I mean, that's mysterious. On the other side, the human blood has a natural pH value of 7 between acidity and alkalinity. Isaac Newton identified the 7 colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. 8. 8 is another composite number like 6. Its proper divisors are 1, 2, and 4, which means you can make an 8 like 2 times 4, or like you can add 2 4s or something, or like add up 4 2s. It's twice 4, 4 times 2. It's the power of 2 also. So like if you cube it, I'll explain what that means later. Exponents will come in 2nd and 3rd grade. So if you take 2 times 2 times 2, you'll get 8. It's the first number which is neither prime nor semi-prime. 8 is the base of the octal number system, which is mostly used with computers. In octal, one digit represents 3 bits. In modern computers, a byte is a grouping of 8 bits, also called an octet. 8 is a Fibonacci number, being 3 plus 5. The next Fibonacci number is 13. 8 is the only positive Fibonacci number, aside from 1. That is a perfect cube. In nuclear physics, it's the second magic number. In particle physics, the eightfold way is used to classify subatomic particles. In statistical mechanics, the 8-vertex model has 8 possible configurations of arrows at each vertex. And in chemistry, 8 is the maximum number of electrons that occupy a valence shell. So 8 is great for chemistry. 9, we got to the end of the road. Now this one is a real mystery here. So some people have been calling the number 9 a mirror, or even a portal, some kind of gateway. So 9 is the magic number. Let's figure this out. So look what happens when you multiply any number by 9. 2 times 9 is 18, 1 plus 8 is 9. Okay, 3 times 9 is 27, 2 plus 7 is 9. Okay, what about 9 times 9, which is 81? 8 plus 1 is also 9. So the product is always 9. It kind of becomes like a projector in that way. But when we add 9 to other digits, it's kind of like invisible. So check this out. 2 plus 9 is 11, which is 1 plus 1, which is 2. And what I'm using here is called recursive addition. Kind of a really fun way to look at the universe and see how numbers are everywhere. So we're just kind of adding digits. Whatever. If we have 2 digits, we're just going to add them until we get 1. If we had 3 digits, we would just keep doing this until we get a single digit. So 3 plus 9 is 12. 1 plus 2 equals 3. And 9 plus 9 is 18. And 1 plus 8, of course, is 9. You get the original number regardless of what happens when you add or subtract 9. So here are the digits, and the modern mathematicians believe it has something to do with the number of angles. So here's 1, there's 2 angles, this is 3. There's 1, 2, 3, 4, 1, 2, 3, 4, 5. Ooh. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Aha. 1, 2, 3, 4, 5, 6, 7, 8. Works. 1, 2, 3, 4, 5, 6, 7, 8, 9. We're good. And 0 is our last number. So what happens when we get to 9? Well, we don't go back to 0. We kind of like put them together and we call it a 10. It kind of starts the next row. We'll get there very soon. So here's the number line. Okay, so everything starts with 0. It's very important that we start with 0. And you don't necessarily have to, but every number line has a 0. Otherwise, the numbers don't work. And it's also flat. I mean, typically it's flat, but again, it doesn't have to be. But typically the number line is flat and it's represented like this, going in two directions. Left usually being the negative and the right usually being the positive. Now, we start at 0 and let's go ahead and count up. 1, 2, 3, 4, 5, 6. We can count backwards. Backwards 1 or -2 or -3, -4, -5, -6. That's the number line. So far I've taught you the digits, and now we've kind of put them together on a number line. Next we're going to learn how to count things and order them. I mean, this whole journey in math is really up to these three questions. All math is answering this question. Is it bigger, is it less than, or is it equal? I mean, it really all comes down to that simple question. All right, so let's just practice a little bit of counting. Okay, so let's see if we can figure out how many strawberries we have. Let's count together. 1, 2, 3, 4, 5. Awesome. Okay, so now we're going to learn a little basic arithmetic. Now, arithmetic is the rules, okay? Adding and subtracting are going to be the first two rules we learn. So we're going to add one, and we're going to take one away, or one less, subtract one. Okay, let's see how that feels. So we have 1, 2, 3, 4, 5 strawberries. Now, which group has one less than 5 strawberries? Okay, so here's the number line again. If you're confused, there's 5. One less than that is 4. Okay, so it's going to be this one, 1, 2, 3, 4. All right, so there it is, 5. One less than that is 4. And then remember I told you about that 10? What happens after 9? Here it is. Oh yeah, by the way, can you tell me what number is in between 7 and 9? Aha, 8, you're right. Yeah, so remember I was telling you about that number 10? That's what it looks like. And it kind of starts the next row. Then we just have like a 10, and we start again. Like 10 plus 1 is 11. And then 10 and a 2 is a 12. 10 and a 3 is 13. 10 and a 4 is 14. 10 and a 5 is 15, 16, 17, 18, 19, and 20. 21, 22, 23, 24, and so on. You can get to 100 this way. Now I want you to practice when your mom or dad come home. I want you to ask for their wallet and count up the dollars that they have and report to them how much money they have. All right, let's practice ordering things. Greater, less than, or equal. Okay, those are your choices. So which group has more? Okay, so let's see. On the top I see 4 ties and I see 5 shirts. Which group has more? Okay, 5 shirts is more than 4 ties. Good job. Now the word fewer means less than, right? So which group has fewer? So we have 5 carrots or 4 snowmen. So 4 snowmen has fewer in that group. Now I know the snowmen are way bigger than the carrot, and this question probably doesn't make too much sense, but you have to read carefully because that's how the test will be in your school. Okay, so which group has fewer? Well, that's this group. There's only 4 snowmen. And then is it equal or not? So let's look. Are the black marbles the same as the blue marbles? Well, what's the question say? What's our chances of picking a marble? So if you didn't see it, what's the chance of picking a blue one versus the chance of picking a black one? Now, I just want you to go with your intuition on this because there's the same number of black marbles as the same number of blue marbles. I would say we're equally likely to pick either one, right? So they're equal. The number of black marbles with the number of blue marbles is not greater. It's not like there's more black marbles than blue marbles. They're equal. All right, let's take a look at how the digits apply to the days. Okay, so this is what a calendar looks like. This is the month of December. And we have to figure out what is the date of the 3rd Monday in December, okay? So let's figure out Monday. Monday's over here. Okay, so here's the first Monday. Second Monday, remember 1, 2, 3, and our third Monday happens to be December 20th. That's my grandpa's birthday, so if it's December 20th, make sure to celebrate. Let's count 5 more days from the 5th. Okay, so we're going to use this concept of counting to unlock and learn addition right away. So let's say it's November 5th, it's Thursday, and let's say Your birthday, you find out, isn't five days from now. Like, what day is your birthday on? So, okay, we need to get 5 more days forward on the calendar till our birthday. So here we go. We're on Thursday the 5th. We're going 1, Friday the 6th, 2, 3, 4, and in 5 days it will be Tuesday the 10th. Good job. Now let's count the number of Fridays. Fridays are always fun. I mean, everybody loves Fridays, right? So in April, how many Fridays are there? How many fun days are there? Well, there's 1 Friday, 2, 3, and 4. There are 4 Fridays in April. And that's how we use counting and basic addition to kind of figure things out in our world. Now let's have a little bit of fun with adding. There's a thing called a sigma code. It's where we add up all the digits in any number and keep doing this until we get a single digit, like 1 through 9. Like, for example, if we look at the New Year's date, 12/31, and we add up the digits 12, 1 plus 2, and 31, 3 plus 1, we'll get 7. It's a mystery number. And that's why I believe people get together and on this day and like make resolutions for the New Year's to come, because it's a mystery number. We can also codify the language using mathematics. Like, for example, so I charted 1 through 9 are our digits, because those are the choices that the sigma code results. So if you just plot A through Z on 1 through 9, now be careful, you can't hit 10 because 10 doesn't exist, so you technically do 9, and then you start with 1 again. So J is in the 9 plus 1, which is the 10th letter. But 1 plus 1, as you already know, if you've been studying, is still a 1 sigma code number. So I've codified the alphabet, and I decided to highlight the vowels in yellow for you to see. A is 1, it's a prime. E is 5, a prime. 9 is 9, the magic number. It's the most important number. It has all the characteristics, and it's the most powerful digit, 1 through 9. I is also the most powerful letter and single letter word in the alphabet because it represents you, an infinite potential of ideas and wisdom. O is 15th in the alphabet, so we do 1 plus 5 and we get 6. It's a composite number. And then U, our final vowel, is the 21st letter, and 2 plus 1 is 3. Guess what? Another prime. So you can use this slide to codify anything in the language world and find the sigma code of it. It's kind of fun. So try this and try to find the sigma code for anything that you interact with in life, such as your own birthday, your phone number, and anything. Have fun, and then if you want, share your ideas in the Facebook group. All right, it's time to do some practice. So when you log into IXL, I want you to click Mathematics, go to first grade, and I want you to find these sections and start here. Okay, so I want you to work through these sections first in this order. A1, counting review, A2, count to fill A10 frame, all the way to A7. And then I want you to practice addition. Okay, start with D1, and it's important that you do this in order, and all the way to D12. And I want you to get at least a minimum of a 50 SMART score before you move on to the next section, okay? Now, 100 SMART score means you've mastered it, so I'll leave that up to you. So here are your action items for first grade. In addition to the recommended problems here, I want you to complete 60 minutes in total time in the first grade. Now I want you to feel free to explore here and jump around. You don't have to get the necessary 50 SMART score in any one category. I just want you to have fun and explore the first grade for 60 minutes. Learn as much as you can. The more mistakes you make, the easier it will be for me to customize your second grade experience. And number 3, I want you to practice the sigma code thing everywhere. Like, have fun with this one and share all your results in the FB group. To finish you guys off with the first grade, this is a quote from Shakatunala Divai. Okay, she was known as the human computer. Like literally, she memorized everything. Her talent earned her a place in the 1982 edition of the Guinness Book of World Records. And she said, "Without mathematics, there's nothing you can do. Everything around you is mathematics. Everything around you is numbers." All right, everyone. I taught you the digits. I taught you how to count up to 100. I taught you basic addition and the calendar and the Sigma code. Very powerful stuff. I want you to go out in the world and enjoy your journey using math. I'll see you in the second grade.